The bell work for today asked you to answer 4 questions related to yesterday's notes. So the first question asks, what is the first thing you must do when solving an absolute value equation or inequality? Well, regardless of whether or not it's an equation or an inequality, you must isolate the absolute value. So that is the first step, regardless of whether or not it is an equation or an inequality. So isolate the absolute value expression. So whatever's inside the absolute value needs to be alone on one side of the equation or on one side of the inequality. Question number 2 says, when solving absolute value equations, what are some important steps to remember? Okay, well, with the equations, we simply have to first isolate the absolute value. And then once we have the absolute value alone, we have to remember to drop the absolute value symbols and set our equation equal to both positive and negative answers. So for example, if I had 2x minus 4 in absolute value is equal to 8, this is the original problem. The absolute value is isolated on one side of the equation. I can now drop the absolute value symbols and have just 2x minus 4, but I have to set it equal to positive 8. Then I have to set 2x minus 4 equal to negative 8. I have to solve both of these possibilities, and then I have to give my answer as x is equal to, and then a list of the possible answers from least to greatest. If it had been set equal to 0, then I would only have one answer. If it had been equal to a negative number, then I would have no solutions because it is impossible for the result of an absolute value to come out to be negative. All right, when solving absolute value inequalities, what are some important steps to remember? So there's a little bit more to remember here. So with absolute value inequalities, again, I have to isolate the absolute value expression. So once I have that, for example, if I have 3x plus 2, if it's alone on one side of the inequality, so say I have greater than 5, I have to drop the absolute value symbols. So I have 3x plus 2. I'm going to write it the way it is first, greater than 5. But then I have to also flip the sign and change the sign of the number on the right. So I would have 3x plus 2 is less than negative 5. So these are the two possibilities I would have to consider with an inequality symbol. If it was the reverse situation, if it started out with a like less than 10, then I would set it up and it would originally be less than 10 or greater than negative 10, and I would have to work both possibilities. What are the major differences between absolute value equations and inequalities? Well, our equations, those are just going to be a couple different possibilities. There's not as many rules. One big thing is that we have to write our answers in a list like we're used to doing, just listing out the possible values for x. So those are just going to be a couple possible values, which is why we list them like this. If we have 2 answers, we'll do least to greatest, like negative 2, 4. If we just have one answer, we'll still just put it in there. And if we have no solutions, we'd say no solutions. Infinite, we'd say infinite solutions. But when I have an absolute value inequality, I have a couple different possibilities. Absolute value inequalities are generally going to come out to be and or statements, just like our compound inequalities. So we would have answers written out as and or statements. And we know there's several different ways those could be written. You could see them in set notation. We haven't really been doing it that way with the compound inequalities. You could have them listed out with the variable in the middle. If it's a and situation, it could also have said x is greater than 5 and x is less than 10. The or has to say or between it. It can't put it all together. I'm not supposed to put it all together like an and statement. We also learned about interval notation. So for this particular situation, I would say with parentheses, because I don't have lines underneath them, that my answers can be found between 5 to 10. So those are just a couple of the things, a refresher of what you looked at last night and what you were supposed to answer on bell work. So going over yesterday's exit slip, the first question should have went ahead and told you what the correct answers were. Just pay close attention to the wording. A lot of times they had the almost exact same answers. They would just change the symbols as far as putting a line under or not putting a line under. They'll say and or, and make sure you didn't accidentally just pick the one that said or when it should have been and. So you just really was paying close attention to the wording described in each scenario. Question number 2 on the exit slip was very much so like yesterday's bell work, where it was talking about the basketball team and the scores. So this particular example is saying that Amaya has already had 2 test scores, 78 and 91, and she's going to take another test, which we don't know the score for yet. She wants to earn a B for the course. In order to do that, she's got to have her average between 80 to 89 inclusive, and that word just means included. It means 80 and 89 could be the possible averages. So we're saying her average, which could be found from adding up the 3 scores and dividing by 3, x, because I don't know what the third one is yet. Her average needs to be greater than or equal to an 80 or less than or equal to an 89. So that's part A, where you're just setting it up. Part B, we need to solve. In order to solve, I need to get rid of the denominator of 3, so I'm going to cancel it out by multiplying everything by 3. And then I get 3 times 80 is 240. 78 plus 91. Let's see, so that's 16. So 169 plus x in the middle. And then 89 times 3. Got 9 times 3 is 27. 3 times 8 is 24. 25, 26. Okay. And then I'm going to minus 169 from each piece to get the x alone. And so when we do that, we should come up with a range between 71 and 98. So those are the possible answers. The answers for the possible scores that she could make in order to receive a B in the course. Part C, Sammy invests money on stocks and makes 7 to 13%. So he could make 7, he could make 13, or he could make anything in between. Calculate the range of his money that he will make if he invests $2,300. So really I'm just saying what is 7% of 2,300, so I can find that by doing 0.07 times 2,300. And then I'm going to find out what 13% is by 0.13 times 2,300. Remember, when you have a percent and you're going back to a decimal, it moves 2 places to the left. So when I calculate those, that's going to give me 161, 299. His investment, his money, could be greater than or equal to 161 or less than or equal to 299. All right, solve and graph the following compound inequalities. So this and statement here, I need to try and get x alone, so I would minus 2 from each side. And have 5 is less than or equal to 5x, which is less than or equal to 20. And then to get rid of the coefficient of 5, I'm going to divide everything by 5. So I have 1 is less than or equal to x, which is less than or equal to 4. So it's saying x is greater than or equal to 1. So I have a closing circle at 1. Or, sorry, I randomly put that there. That shouldn't be there. It was originally just a less than. So it should be or less than 4. So if it's less than 4, it's got an open circle, and it's less than. Since it's an and statement, it has to be where these things overlap. I can't include the parts where they don't overlap. This part where they're overlapping is the solution because it's an and inequality. The very last one here was an or statement, so I know if I do everything right and if it's a normal answer, it should be facing opposite directions with no overlap. So if I solve each independently, each piece, the first part I'm going to get rid of the negative 4 by dividing both sides by it. So I've got p, and I've got 12 divided by negative 4 is negative 3, but I just divided by a negative number on both sides, so my sign must flip. On the second one, I'm going to minus 8 from both sides, and that will give me negative 2p is less than 4. Divide by the coefficient of negative 2. So I've got p, and 4 divided by negative 2 is negative 2, but I just divided by a negative again on both sides. My sign needs to flip. So less than or equal to negative 3, circle filled in and to the left of negative 3. And then greater than negative 2, so open circle to the right of negative 2. So now that we've gone over the bell work and yesterday's exit slip, we're actually going to do a really thorough recap of all the different things that you've learned last night, because there's a bunch of different little pieces that we've got to keep straight. So these notes are just going to be an extra resource for you to really dig into what are all the possible things that could happen with absolute value equations or inequalities. We just want you to be thoroughly prepared. So absolute value, if we are working with an equation, those are not quite so scary. There are minimal things that could happen. So I know I have to first isolate it. Like we said, I have to have the absolute value by itself. There's 3 possibilities. Once I get the absolute value on one side of the equation by itself, it could come out to equal 0, a negative, or a positive number on the right side. So if it comes out to be set equal to 0, we remove the absolute value symbols and solve to get exactly one solution. If the absolute value is set to a negative number, that's impossible. I could never work out something inside of an absolute value and get a negative number, therefore there's no solutions. And if it is set equal to a positive number, that's when we need to set the argument, or also known as the expression within the absolute value, equal to the number, and then also set it equal to the opposite, basically the negative of that number, using an or statement in between to give the 2 equations. Okay, so then we'll get 2 separate solutions. So let's look at a couple of examples of those. So if I had this original equation, absolute value equation, first I would have to clean it up and get the absolute value expression alone before I continue solving. So I have this plus 7 over here with it. I need to move it to the other side. So I'd have to minus 7 from both sides, and that would leave me with 0. Now that I have the absolute value expression alone, and it's set equal to 0, well, usually we would set it to this and then the negative version of this. Well, 0 doesn't have a positive or negative. It's neutral. This is why we only do it one time and we only get one solution. So I just drop the absolute value symbols, set it equal to 0, and solve for that value. So the only answer for this particular one is that x is negative 4. So on the number line, I would just have that one answer. Option B was if it was to come out negative. So if I cleaned it up and I minus 7 from both sides and I get a negative 5, I know that there's nothing that I could put in here and generate inside of an absolute value to get a negative number. So there's no solutions. On my number line, if I were to graph it, there would be nothing there. If they told me graph the solutions to this, I would just leave it blank because there are no solutions, nothing possible. Last scenario was if it came out positive, so I clean it up, I move the 7 over, comes out to equal 2, so then I set it up to equal 2 and negative 2, solve for these possibilities, so these are the 2 possibilities, and so I've got 3 and 5/3, actually 5/3 is the smaller answer, so I'm going to say 5/3 first, and then 3. So it wouldn't be wrong if you wrote it the other way, but we're trying to keep good habits here of writing our answers from least to greatest. So the other possibility is if one absolute value expression equals another absolute value expression. So what we do here is we kind of take the one on the left as the default absolute value, and the one on the right side we're going to use, just like we would some of the other answers, we're going to drop the absolute value symbols. We're going to consider that it's worth the positive version of 2x minus 1, or in parentheses, the negative version of 2x minus 1. The negative one is very key because if the negative is in front of the parentheses, I've got to remember that that's like a negative 1 being distributed to both things inside of there. So once we do that, we're going to work both versions. The first one comes out to be x equals 6. The next one, when I work it out, get my variables together on the same side, combine like terms, move over, divide by the coefficient, and our answer is negative 4/3. Okay, so this one, if we were to write it in the way that we've been asking you, would be negative 4/3, comma 6. So now that we've recapped the equations, we need to dig into the absolute value inequalities. So there's 3 possibilities here as well. It could come out to have 0, positive, and negative numbers on the right side. So you always, always, always need to get the absolute value expression isolated. It needs to be alone on one side before I can make any judgment calls about what my answer is going to look like. If it comes out to have a 0 on the right side, there's a couple different things. If it comes out to be less than 0, just a less than, there's no solution because the only numbers that are less than 0 are negatives. And again, our absolute value expression cannot come out to equal a negative number. If, however, it's greater than or equal to 0, then greater than or equal to 0 is all real numbers. So I'm going to have infinite solutions. So that's because for an absolute value, it's always going to be greater than or equal to 0. Always. Everything that I plug in there would make it greater than or equal to 0 because absolute value turns everything positive. Okay? So the last scenario is if instead it was greater than 0, then I have to actually do a little bit of more work because greater than 0 means that it is the positive numbers, but it cannot equal 0. So greater than 0, we actually have to work it out and figure out which number would make it 0, because that's the one thing it cannot be. So we'll find out what that is, and we'll write our answer as a union of the answers except for the one that makes it 0. So we're about to take a look at what those might look like. A negative number, if it comes out to be less than or equal to a negative number, there's no solution. Again, it cannot be coming out to equal a negative number. If the absolute value is greater than or equal to a negative number, then the solution's technically going to be all real numbers because the absolute value will always be greater than a negative number. The last possibility is if it comes out to be a positive number. And so these are the ones that generally take a little bit more working out to get a final answer. So if the absolute value is less than or equal to a positive number, it can be approached in 2 ways. Either solution will be written as an intersection, so that really means and. We're talking about and things here. And then another symbol I want you to know for how they'll represent and is there's this symbol that looks like an upside down U. It means and. So if I were to have like negative infinity to 4 and, well, that doesn't make sense. But instead of writing something like negative 2 is less than or equal to x, which is less than or equal to 8, we learned that we could also say x is greater than or equal to negative 2 and x is less than or equal to 8. Well, sometimes when they write it in interval notation, this would be saying that it's going to be negative 2 to 8. So this would be like negative 2 to 8. But sometimes they write it out with this symbol in between, and it means and. So just, you don't see it quite so much here, but you'll see that symbol a little bit later, and I want you to understand what that symbol means. So From there, we've got a three-part inequality, a compound one between the opposite of the number and the number. So again, we're flipping the sign and changing the number. Okay. If the absolute value is greater than or equal to a positive number, so then we're going to do the same thing that we did. We're going to flip the sign and change it to the negative and solve both situations. But this time it says a union of the two solutions. So union is when we're talking about or. And the symbol for a union is like a U. So and is like a N, or looks like an upside down U really, or for union is a U like that. So that would be written in between. This one's a little bit easier to think of, like if I were to say negative infinity to 5 or 7 to positive infinity. So that's like an or statement if you ever see that. That's what that means. Okay, graph the answer in number line and write the answer in interval notation. So on this particular section of the notes, I want to give you a little kind of acronym to help you remember if something was supposed to be a greater than compound inequality or a less than compound inequality, to tell you if it's going to be an and. So go LA, maybe some of you will say GOLA, I don't know, I don't say that, but go LA. If once I clean up the inequality and I have the absolute value expression by itself, if I do that and I'm left with a greater than or equal to symbol, I know this is supposed to be an or inequality. If I have cleaned everything up and the absolute value expression is alone and I have a less than or equal to symbol, that is really supposed to be an and inequality. So go LA. If it was greater than when I clean it up, it should be an or statement. If it was less than when I clean it up, it should be an and statement. So this is particularly helpful with absolute value inequalities. So let's actually look at some examples of each. So the first things we looked at were if it was dealing with 0. So if it's cleaned up and we know that it says it's anything greater than or equal to 0, because it specifically says greater than or equal to, I know that that's all real numbers, because anything I plug in here is going to be greater than or equal to 0. For part B, I have to clean it up. I would have to minus 4 from both sides, and it ends up being less than 0. So there's no equal sign under there. It's just saying less than 0. Well, there's nothing I can plug in there to make it come out to be less than 0, because that would be negative, so that's no solutions. The third option here, third example, I've got to get it alone. I would have to add 3 to both sides, which is where we get it to be 0 on the right side. So because it says less than or equal to 0, this is where I'm just trying to find out what's that one number in there that will make it 0, because that's the only possibility that could happen. That's okay. So I just take x plus 1 and I set it equal to 0 to find out what that number would be. Many of us can already see it's going to be negative 1. So the only answer for this one would be negative 1. That's the only possible answer that this could be. All right. So on option D, we've got 3x plus 4 inside the absolute value with a plus 5. I need to move that over. And that gives me a result that's a negative number, and that's not okay. I can't have less than or equal to a negative, because that's impossible. I can't put anything in there to generate a negative number. E, I move over the 4 to clean it up, get a 6. That's okay. So now I divide by 2 to get it completely alone, and I get a 3. So I have it greater than or equal to a positive number, so I can proceed and actually solve this. So remember the little go LA thing I told you, once it's cleaned up here, since this is a greater than symbol, this means it should be an or statement. So once I set it up, I'm going to drop the inequality symbols, drop the absolute value signs, and use the original greater than or equal to 3, or I'm going to have x minus 1, flip the sign, and change the sign of the number, so less than or equal to negative 3. When we work this out, we come out with x is greater than or equal to 4 or less than or equal to negative 2. So if I were to graph this on the little number line here, at negative 2 and at positive 4, it says less than or equal to negative 2, so I got a closed circle at negative 2 going less than, greater than or equal to 4. That is an or statement. It's doing exactly what it should be doing. I taught you that if we're writing things in interval notation, we read them from left to right. So the first part of my answer, I see negative infinity first, and then it stops at a negative 2, and that's a shaded in dot, which is why it's included. Or, I can use that or the union symbol here. The next part of my answers are found at 4. It's filled in, which is why it gets a bracket, and it keeps going to positive infinity. We don't put brackets around infinity because you can't be equal to it. The last example on this page, F, I would clean it up, move the 6 over, and then this gives me negative 10, but because it says greater than or equal to, well, anything I put in there is going to be greater than or equal to a negative number, which is why it's infinite solutions. So I want to actually take this page to also say this in a little bit of a different way. So this first example, D, this, when I cleaned it up, was a less than or equal to sign. And so if I forgot that this can't work, I could remember that this is a and statement. And let's just say I forgot this is no solutions and I continue trying to work it. So I would have 3x plus 4 is less than or equal to negative 2. And then 3x plus 4 is greater than or equal to positive 2. Because I kept the original one, then I flipped the sign and changed the sign on the number. So I continue to work this. I move the 4 over, which gives me negative 6, and then I divide negative 6 by positive 3, and I get x is less than or equal to negative 2. Do the next one, I minus 4 from both sides. I get 3x is greater than or equal to a negative 2. When I divide by 3 on both sides, I get x is greater than or equal to a negative 2/3. So if I were to go to try and graph this, I would have x is less than or equal to negative 2. So at negative 2, I would have a shaded in circle and it would be going to the left. And then at negative 2/3, which is a little down here closer to 0, I have greater than or equal to negative 2/3. Well, when I graphed this, it came out to be an or, and it originally started as an and. So a little tip here is if an and statement, like you know the rules and you know it's supposed to become an and at the end of it, if an and statement comes out to be graphed like an or statement, so and becomes an or, this is always going to result in no solutions. Because and is supposed to be where they overlap, and an or on the graph has no overlap. So I'll take option F here and show you the reverse. So I know that once I cleaned it up, it says greater than or equal to, and from the Go LA thing, I know greater than represents or statements. So this means my final results should come out to be like an or statement. So say I forget this little trick and instead I continue working it out. I would say x minus 6 is greater than or equal to negative 10. That's the original situation. X minus 6 is less than or equal to positive 10. So if I work each one of these by adding 6 to both sides, I get x is greater than or equal to 6 minus 10 will give me a negative 4. Add 6 this way and I'll get x is less than or equal to 16. So if I go to try and graph this, I've got at negative 4 down here, closed in circle going to the right. At a positive 16, I've got another closed in circle going to the left forever. And if it's originally supposed to be or, it only technically has to be one or the other, or it could be both, but it only has to be one at a time. Well, if it could be everything this way, and it could also be everything this way, then it could be any number. So if an or, something I know when I clean it out is supposed to become an or, turns into an and on my graph, that will always result in infinite solutions. So if an and magically, well not magically, but turns out to be an or, we know solution. If an or turns into an and, that's infinite. But for many of us, we're going to start realizing, well, hey, I already know this can't happen. Oh, well, I know this will always happen. So you don't always have to go that far. I just wanted to show you what would happen if you did. So they give us a couple more examples. We've got if 2 minus x is less than 8, so I'm trying to remember these rules. Less than means it's going to be an and statement, so clearly these people made a little bit of a mistake. I'm going to scratch these ors out because I don't want to use that language, and I'm going to say and. So set one side, 2 minus x is less than 8, the normal way. 2 minus x is greater than negative 8, so I've changed the sign and changed the sign on the number. So when I minus 2 from both sides, this should actually be a positive 6. And so I've got a negative x, though. I've got to divide by negative 1 on both sides to make that x positive. And so that's going to change my inequality sign, and it's going to leave me with x is greater than a negative 6. On the right side, I'll minus 2. Negative 8 minus 2 is negative 10. I'll divide by the negative 1. And so that's going to flip my sign again, and a negative divided by a negative is positive. So in interval notation, because there's no equals to underneath the lines, they're not included, I'm going to have parentheses from 6 to 10. On the number line, if I needed to graph it, I know at 6 there's an open circle. At 10 there's an open circle, and the answers are found between 6 and 10. You could have also seen your answer written with the x in the middle, and I'm saying it's greater than 6 and less than 10. All right, the middle one here, I need to get rid of the 3 out front. It's multiplying, so I'm going to divide both sides by 3, which is how I get a 3 over to the right. And so for this particular one, you could come out and work it 2 different ways, so we're going to come back to that one in just a second. For I, this is just saying greater than 0. So because there's not like an equals to sign there, we said I have to actually see what is the number that makes it equal 0, because that's the one number it cannot be. So on the number line, I can plug in anything but negative 6. Because negative 6 is the one thing that if I solve it here will make this 0, and it can't be equal to 0 because there's not a line under it. So any negative number I plug in here, say I do negative 10 plus 6, even though it comes out to be negative 4 inside the absolute value, it's really a positive 4, which is greater than 0. If I plug in any positive number, if I plug in 8 plus 6, will give me 14, and the absolute value of 14 is still greater than 0. So I can have any negative number and any positive number. The only number that I cannot have is negative 6. So for this one, it's not quite infinite solutions, it's almost infinite solutions. It's the only thing it cannot be is negative 6. So if we have just a greater than 0 situation here, we've got to figure out what's that one number that would make it equal to 0, because that's the one thing it cannot be. So for that middle option, we're going to look at 2 different ways it could be written. You could split it into 2 separate ones and work them, remembering that because it was a less than, this should come out to be an and statement. So you could do that, work them out, and get your 2 answers. Or you could keep it all together, because that's just another way to write an and statement. So I could say 4x minus 1, and I have the original version, which just stays over here, less than or equal to 3. But then when I try it the other way and I say that it's greater than or equal to negative 3, that would just go on the other side of the inequality. So if you're more comfortable writing out as 2 separate ones, that's fine. Just know that you can also go ahead and put it together the way we're used to and solving it until you get just the x in the middle, and you'll still come out with the same answers. Okay, so we've covered a lot. We've looked at special cases of when it can become no solutions, infinite solutions. Sometimes there's only one possible solution. With the inequalities greater than 0, it's everything except for one possible solution. There's quite a great deal of things to remember, which is why you have this extra resource sheet. I hope that helped. At this time, the only thing you have left to do is a 2.8 practice on Go Formative. It is a grade, which is why you don't have any additional homework tonight. It is just going to be practice for your quick check tomorrow, and it is the only homework you have. You don't have any notes or anything like that tonight. You just need to work on this Go Formative. It should show you red or green as you're working, and then you just do your best. And tomorrow when you come into class, we will answer any questions that you have remaining about that practice, do a little bit more practice, and then at the end of class, we'll take your quick check on everything between 2.5 to 2.8.